Question 1 says the structure of a soap molecule contains a hydrophilic head and a hydrophobic tail. What solvent or solvents the molecule will be soluble in? So what we have to know first, hydrophilic means polar and hydrophobic means non-polar. And in chemistry we have a rule of thumb that says like dissolves like, which means polar will dissolve in polar, in non-polar to non-polar. So the molecule contains both polar and non-polar parts. So that means it will be soluble in water and oil, since water is polar and oil is non-polar. So our answer is C. So in question 2 we have what is the molecular shape and the hybridization of the nitrogen atom in ammonia molecule. So what we have to do first is to draw the Lewis structure of ammonia to find out the answer. So the Lewis structure of ammonia goes like, and then count the electron domains. So we have 1, 2, 3, 4 electron domains, and we have a lone pair, which will give us a trigonal pyramidal shape. And find the hybridization of nitrogen, we have to count the electron domains and then subtract 1. We have 4 electron domains, and 4 minus 1, that gives us 3. So the nitrogen atom is sp3 hybridized. So our answer is D. Question 3 says what is the best description of the carbon to oxygen bond length in carbonate? So what to do first is to determine the Lewis structure of carbonate. So if we look at the structure, we have a double bond from one oxygen and single bonds from the other 2 oxygens. And in chemistry you have learned about bond length, and according to bond length theory, double bonds are shorter than single bonds, which means there are 2 long and 1 short bond. But however, carbonate have resonance structures. It can be drawn as and so, which means all oxygen can form this double bond. So the resonance hybridized structure of carbonate is drawn as and this means all bonds are equivalent. So our answer is answer A, we have 1 short and 2 long bonds, B 1 long and 2 short bonds, and C we have 3 bonds of the same length. So C is our answer. Since carbonate can show resonance, so if we draw the resonance hybridized structure of carbonate, it shows that all oxygen have the same bond length. Question 4 says, which statement is correct about multiple bonding between carbon atoms? A. Double bonds are formed by 2 pi bonds. That's not correct. Double bonds are formed by 1 pi bond and 1 sigma bond. B. Double bonds are weaker than single bonds. That's not correct either, because double bonds are stronger than single bonds, because double bonds have a sigma and a pi bond, and the single bond have only sigma bonds. So double bonds are stronger than than single bonds. And C, we have pi bonds are formed by overlap between s orbitals, and that's not correct, because pi bonds are formed by the overlapping of the unhybridized p orbitals. And D, we have pi bonds are weaker than sigma bonds, and that's correct. So our answer is D. In question 5, we have, which of the following metals has the strongest metallic bond? So what we have to do first is to determine and to define the word metallic bonding. Metallic bonding means when metals form a lattice and then they lose their valency electrons to form a sea of mobile electrons, or the so-called delocalized electrons. So we can draw it. So this is the giant lattice metal structure, which is positive, and these atoms, they lose their valence electrons. To form a sea of mobile electrons. And if we look at the elements they gave us in A, B, C, sodium, magnesium, and aluminium, sodium has 1 valence electron, and magnesium has 2, and aluminium has 3. So aluminium will have a strong metallic bond since it has the most number of valence electrons. So it will form the biggest number of mobile electrons. So the answer is C. Question 6 says, you have 4 different samples of compounds that are liquid at room temperature. Boron trichloride, carbon tetrachloride, nitrogen trichloride, and oxygen dichloride. Identify which correct pairs of molecules that are capable of forming a solution. So to answer such a question, we have to draw the Lewis structures first and identify polar and nonpolar molecules. So for boron, so the charges on boron trichloride will cancel out and leaves it a nonpolar molecule. So does the carbon tetrachloride. This will cancel out and leaves it a nonpolar. And for nitrogen trichloride and oxygen dichloride, the central atoms have lone pairs, which makes them polar. So that means nitrogen trichloride and oxygen dichloride, they will go together and these are polar molecules. And for boron trichloride and carbon tetrachloride will go together because like dissolves like. Polar will go with polar and non-polar with non-polar. So our answer is A. Question 7 says, what is the geometry of the bonds around an atom with sp2 hybridization? So to find the hybridization of an atom, you have to count the electron domains and then subtract one as we saw earlier. So that means the atom will be bonded to three atoms since it's sp2 hybridized. So let's say the atom is X. It will be bonded to A. And if we count the electron domains, we have 1, 2, 3. And 3 minus 1, that gives us 2, and which makes sp2 hybridized. So that means our answer is B. 3 bonds at 120 degrees. So question number 8 says, how many sigma and pi bonds are present in the structure of hydrogen cyanide? So what we have to do first is to draw the Lewis structure of hydrogen cyanide. So hydrogen cyanide. Hydrogen makes only one bond. And 1, 2, 3, 1, 2, 3, 8. So have a lone pair on nitrogen atom. So we have to find the number of sigma and pi bonds. So we have 1 sigma bond and here 1 sigma bond. So we have 2 sigma. And we have 1 to the pi bond. So we have 2 pi bonds. So our answer is A. We have 1, 3, 2, 3. So our answer is C. 2 sigma and 2 pi bonds. Number 9 says, which of the following best describes the bond formed between sulfur and oxygen? A. Ionic bond, B. Metallic bond, C. Polar covalent bond, and D. Non-polar covalent bond. So what we have to know first is that this is neither metallic nor ionic bond, since we are dealing with nonmetals. So this is a covalent bond, but which type of covalent bond? Is it polar or non-polar? And we have to find out the electronegativities for both atoms. And if the difference between the two electronegativity is below 0.5, that means it's a non-polar. And if the difference between the two electronegativities is above or starting from 0.5 above, that's a polar covalent bond. And sulfur has 2.58 electronegativity value, and oxygen has 3.44 electronegativity values. And if we subtract 3.44 minus 2.58, we get 0.86, and this is above 0.5. That means this is a polar covalent bond. So the bonds formed between sulfur and oxygen are called polar covalent bonds.